In this video, we're going to talk about built-in types in the Python language, or standard types. There are three main categories of types that we're going to discuss: numerics, sequences, and mappings. Numerics are what they sound like. They're numbers. And you have integers, floats, and complex. We'll talk about the first two, but I am not going to get into complex numbers. So an integer is just what you think it is. It's a number. And in Python, integers are effectively unlimited in size. Now, they will be limited by the amount of memory you have, but they're not tied to like 32 or 64-bit. They use something called arbitrary precision arithmetic, and they're defined by C structures underneath them. So you can have very large numbers in Python. I mean, that's a huge number, and you're not going to have any kind of overflow. You can notice that if you start to get to absurdly big numbers, you will be limited by the amount of memory you have. You can see right here the free memory starting to drop significantly because Python's using that memory to try to come up with that big number. And as soon as we stop doing that, we get the memory back. So from a technical perspective, the size of the integer is unlimited, but there is a practical limit based on the amount of system memory you have. Floats are generally just C doubles. So in terms of precision, you're going to be generally limited to what a double would be. Sequences are groups of things, and they have common operations, such as checking to see if there's an item in a sequence, slicing it, getting the length of it. Sequences are things like lists, tuples, and ranges. Text is also considered a sequence, and we'll cover that later. But a list is a mutable sequence of typically like items. So x equals 1, 2, 3. This is a sequence of integers. Notice that I used the square bracket. The square bracket is how you denote something in Python as a list as opposed to a tuple, and we'll talk about tuples next. Now, the items in a list do not have to be like items. You can mix integers, strings, floats, and that's perfectly fine. You can also modify lists. They are what's called mutable, which means you're capable of changing it. You can append to that list, and you can remove things from that list. So let's talk about tuples. Now, before I get into that, I would like to cover something semi-controversial, and that's the pronunciation of the word tuple. We had this debate in our office a while ago, and so I looked it up on the internet, and unfortunately there is no consensus on exactly how to pronounce this word. It comes from words like quadruple and quintuple, and if you think about it, typically people pronounce those words differently, even though they have the same suffix. The etymology is actually a little bit interesting. You take the word quintuple and quintus, the Latin, meaning fifth, and then the plus is the suffix root, and that means fold or more. It happens to be the same root as the word plural. I just thought that was interesting. So I'm going to pronounce the word tuple. You may prefer the pronunciation tuple, tomato, tomato. But a tuple is immutable. It's very similar to a list, except it can't be changed. And tuples are denoted with parentheses instead of square brackets. Notice if I try to append to this tuple, it's not going to let me because it's not supported for that object type. I can't change this. It's immutable. Another example of an immutable sequence of numbers is a range. Technically in Python, range is a type, so I can assign it to a variable. And if I look at the type of x, you can see that it's a range. Now I can convert it to a list, and you can see that it's just the numbers 0 through 9. It's effectively a sequence of numbers, but it's immutable. You can't modify a range object. And in terms of usability, what you use a range for mostly is to iterate through that sequence of numbers without having to create an intermediary object. So for example, I can say for number in range 1 through 100, show me the number. Notice it stops at 99 because the range is inclusive and exclusive. So the first number will be included, the last number will not be included. You can also do things like provide a step. So you could say for number in range 0 through 20, count by 5s. And of course, if you omit both of these and just go with the first number, then the 0 is implied. So if I say for number in range 10, it's really saying 0, 10, same thing. Finally, in terms of sequences, I want to mention strings, which are technically immutable sequences of Unicode code points. So I think I mentioned in one of the Hangman videos, that's what's cool about strings, is that because they're essentially considered sequences, you can do things like check for instances within them. So you can say, you know, if t in the, and it does, because this is a sequence of letters and the t is in that sequence. So think of it as like an array of letters, basically. Strings can be either single quoted, double quoted, or even triple quoted. And these can be triple doubles. With the triple quotes, you can also put them on multiple lines. The strings have a lot of the same common operations as other sequences, like slicing, checking for we mentioned checking for the items in the sequences, getting the length. They also have their own operations, such as join, split, and strip. And as I was going through the documentation to make this video, I came across an interesting operation I'd never seen before called center. And you can effectively take a string and center it. And you could even specify the padding. So if you want the word cat centered in a bunch of periods, that's how you do it. I didn't know this existed. It's kind of pretty cool. There are other sequence types that I'm not going to talk about: bytes, bytes array, memory view. As usual, there'll be links below if you wanted to get even further into details on the different built-in types. Another standard built-in type are mappings. And as of right now, there is only one standard mapping type, and that's a dictionary. So a dictionary is essentially a key value pair. And so if we can create a dictionary, and we could use the name and the age, for example. And these strings, which are immutable sequences of letters, become the key, and then these integers are the values. You can have any immutable object as the key. So in other words, you could create an object, for example, student, and you could then use that object you've created as the key, and then these values could be their grades or whatever. But if you want to do that, not only does the key have to be immutable, it also has to support the hash method. So being hashable means that it has a hash value which never changes during its lifetime. You have to essentially be able to say it's unique across its life. If I create a student in our previous example, I have to be able to differentiate between the different students. Strings are immutable. You know, Sam, it's not the same thing as sprinkles. That's obvious. Now, there are other built-in types such as context managers and classes, but those will be handled in their own separate videos. And the last unique type I do want to talk about is the null object, of which there's exactly one, and it's none. None is returned by functions that don't explicitly return a value. So for example, let's say we create a function called foo, and it prints something. And then I assign the return value of foo to a variable. It still does the print, but what's x? Well, x is none. It's the none type. The none type supports no special operations. So that is the overview of the built-in types in the Python language.